we go. Okay, so this stream, I know I've been doing the Game Boy Advance stuff the last couple streams, but I was thinking I could take a quick break from this. Pulling up stuff here. I was thinking I could take a quick break from that and show you some of the other projects I've been doing. I will probably revisit. I will definitely revisit the Game Boy Advance project. But it's just C stuff, and I want to get sort of into other hobby-related but work-related stuff. So anyway, just looking here. So this here is a TI-84 Plus, right? Got one right here too. Unfortunately, this isn't my original. This has a few apps on it. I used to be really into these calculators. I had 36 at one point, 36 different graphing calculators. I sort of waned in interest over time because instead of school, I was doing an actual job that didn't really require these. But I always want to return to form and get into them again because they're fun, they're fantastic to learn on, and they're actually quite pertinent to what I'm doing in work right now for a bit of programming. So this is a TI-84 Plus. It runs on the Zilog Z80 processor, which is the same thing with Game Boy. Not the Game Boy Advance, but the original Game Boy had. And the Game Boy Advance actually had a separate chip, which is an ASIC that is a Z80. So the CPU in here, it isn't have a good moment. Do I not have a Z80 kicking around? It might be in my car. So the chip inside this calculator isn't like one of these. This isn't actually a Z80. I have to think of a Z80 in my car. This here is a 65C816SP. I want to say that is a 16-bit version of the 6502. And the other chip in here, which I have no idea how I'm ever going to use, is an Intersil 1000. An Intersil 6100, that's what it is. And the Intersil 6100 is a system on a chip for the PDP-8, the DEC PDP-8 computer. Now, you have to have your separate RAM and your separate ROM, but I think everything else is I think it has its own like memory management stuff and things on it. So anyway, as I was saying, the chip in the TI-84 Plus is not a physical. I mean, long ago on the T81, I think it was a physical chip with a physical ROM chip. Now it's an ASIC. It's with tons and tons of GPIO pins, and I think it emulates a. I'm gonna get this wrong. It's a Z80, but it has a 20-bit address bus instead of a 16-bit address bus. I think I could be. It either has a 20-bit address bus or a 24-bit address bus. No, I think it's a 20-bit address bus, but I was told how the addressing works, but whatever. Anyway, So you can program these things using things like TI Basic, where you literally just, you know, you might remember this from school. You go to new, you create your own program, and then you program this stuff on the calculator. You can use assembly, which is Zilog Z80 assembly, which is very similar to 8080 assembly, but apparently Zilog and Intel had a falling out with like who owns the licensing to the opcodes. So the opcodes, even though some of them are the same, actually are named a little differently. You can program these in C, which I've done before, and I will do that in the future. Again, I will like try to figure. If no one has, I want to sit down and figure out a C header file for this calculator because I think that would be ideal and really awesome. It is a Zilog Z80 chip. It's just the memory map is a little strange. Also, there's a weird thing where you can't have an executable portion of the code larger than 8.111 kilobytes. I don't know why. It's something security. I know that if you have a program called apps, if you have a program called ZStart, like this, and let me just try to hardware. If you can do something called execute greater than C0000, and I think what that means is you can now have programs larger than 8.1 kilobytes, but don't quote me. Anyway, the language I want to focus on is Axe. And what is Axe? Axe is a very, I would almost say it is a C-like language. This was, the final version was released in 2012, so quite a bit ago nowadays. Doesn't feel long ago to me. But it is a C-like language. I would almost consider it something like PLI or PLM. PL1, yeah, or something like that. It is a, basically it's like one step above a assembly in terms of complexity and stuff, which is I think kind of what Axe is. It has data structures, but it doesn't have structs. It has while loops, just for loops, and if statements and things like that. In fact, it has many control statements and things like that. It's very awesome. But if you know anything about Z80 assembly, then you can quickly look at these things, and even a little bit about the calculator hardware and how it works, just on a basic level. You can look at this and realize, oh, this is actually fairly easy to translate into assembly. Variables are 8 bits by default. If you want a 16-bit number, you have to put an R in front of it. There's 3 buffers. There's the main buffer, there's the back buffer, and then there's like an at buffer for the screen. There's text shadow, which holds the text that's on the screen while you're doing something else. Pixel on, pixel off, pixel change. How does the screen buffer work? That sort of thing. Anyway, I'm going to send this program over. I'm using the justified emulator because it's the best. And this program, Chematech, is the best place to go. It has a wonderful editor where you can choose between TI Basic, Axe, ICE, which is sort of a Axe-like language for the TI-84 plus CE, which I have at work. I don't have it with me right here. And Z80 assembly, EZ80, EZ80C, all built into the web, and it's really awesome. This is the live chat for the website. People are on and about. Anyway, so I sent the files over. I'm going to go to Axe, going to hit compile. I'm gonna compile the program. I'm gonna run this through doors CS because I love doors CS. And here we go. I have my little character moving around the screen. I know I haven't taken you a tour through the code yet, but I will. And the problem I'm having right now is it's not scrolling. There's no scrolling. Hopefully tonight we're gonna fix that. And how Patrick, is this pertinent to your work? Well, because I have a similar LCD problem at work where I need to figure out how to scroll stuff on it. It's kind of a problem. So if you look at my character, I have a local XY position, right? But I also have a screen XY position that starts up here. Right now it's being drawn at 0, 0. If I move over to the right, I want it to be drawn at, like, you know, start drawing at 1 or something, or 2 or stuff like that. That's what I want to do. So, luckily, I have asked how to do this a while ago, and someone has responded to me with some helpful tips. The code doesn't work exactly the way, I mean, it does. It's just not what I wanted, so I had to do some changes to it. But it's totally fine. It's really helped me out. Also, there's just strange quirks to this. Let me try to take you in to what's actually going on. So this is my Axe source code. So anything with a period is a comment. There. One moment. What is going on? One moment. We're just gonna pop that in there. Anyway, so anything starting with a period in this language is a comment. The first comment with the first word is the name of the program. So if you go here, you see if I hit 3 or down here, hit enter, I can now launch the program. And then this is just a description of the program. I think, don't quote me, but I think this is something that you would mouse over. No, never mind, it's not. I thought it was a mouse over description in DoorCS. Anyway, diagnostic off just I think it makes it go fast. Program floor to source is include this program. Basically, I have the wall sprite, I have the floor sprite, and then I have the stair sprite, and then the whole map is nothing but a one-dimensional tile map. It's a very strange way that Axe has done these. I would think that you would have your tile map and then have this at the very end, but no, it's fine, it's fine. This is how you do one-dimensional arrays. G and H is the size of this array because it is a one-dimensional array, so you can't tell how big it is. There is no size of, at least not that I know of. So yeah, this is the map. It's just the tile map with 0 is, like pick 0, is the wall, 1 is the floor, and 2 is the stairs. And if you notice, I have the wall, floor, stairs all together. That's so I can very easily draw it, because when you do this in X, you have literally physically in a block of memory, you have the first sprite, and then the next sprite, and then the next sprite fit contiguously in a block. If I did something like this, I couldn't do that anymore, because I now have two 8-bit variables in the way. So there, and then if we go back to rogue source, I have diagnostic off, which I think, one moment, which I think is diagnostic off, turns off run indicator. Sorry. So basically, when you do your program, you might see like a run bar in the top right. That's actually, it'll get rid of that. Then I have the player sprite, and then I have the monster sprite. I don't have any monsters right yet, so yeah. Get calc temporam is basically just I want a chunk of RAM, and I want it to be 12 bytes, and I need to store that pointer to A. So there we go. Player X, player Y, camera X, camera Y are now stored into the location in RAM pointed to A. Now the _R is actually let's see, probably a faster way to find this, is actually this character, the small r. So when you do this in X, you it modifies a base. It modifies the base. And if we look at expression R, I'm just looking for it. Looking for it. Let me just look. I know it's here. Okay, so come on, really? Here we go. So, right, if you look at just A in brackets, it is a 8-bit location RAM, but if you do a single radian, you do a 2-byte value, so it's now a 16-bit value, a sort of short. A double radian is a short, but it's big endian. In reverse order, so the low byte will be first. I don't know. What troubles me is this guy says for the camera to have the reverse order bytes, which to me makes no sense. Why would I need to have reverse order bytes? That's kind of strange. So I got rid of them. I kept the oh my god. I kept the radian sign, because if you look at this game, you might say to yourself, oh, they're 8x8 tiles, so why don't you just do 1, 2, 3, just offsets of 1 and 2 or whatever. I could, but these are pixels. So that's why player instead of 1 is 8. So I could fill up the buffer. I could fill up the 256. 256 divided by 8, it could be 32. I could fill it up pretty quick. So that's why I have 16-bit values instead of 8-bit values. Whew. Then I have repeat get key. Repeat get key is a function that repeat and then end. So basically it's a while loop. So while get key does not equal 15. 15 is the clear. So I want to keep running this code while I don't hit the clear button. And once I hit the clear button, I hit the return, and of course return will pop me back out to the OS. That's essentially an exit. So this I have is if get key equals 4, 1, 2, 3 in Axe, the oh my god, the arrow keys are mapped to 1, 2, 3, 4 that you can grab by using the get key function. These aren't the same numbers that you have in TI Basic, but I think in Axe it's just a lot more intuitive, I would say. Yeah, it's just a lot more intuitive. The question mark is an and. So basically, if get key equals 4 and tch with the variables x and y1 minus 1. And what is tch? Tch is my player, what you call it? Collision detection. And you may be wondering to yourself, how does that even work? Well, you may be asking, what are the U and V? Well, to be honest, I don't actually have it. Let's try that. Yep, there we go. It works. Still collision. Okay. So all this is well, you know how it works. Y times width. So how many lines down plus X. So yeah, how many lines down are you plus X? That's just how, that's just how you do two-dimensional accesses in a one-dimensional array. It's very awesome. Yo, Desp, what's that? What do you mean? Can you like ping? Oh, do you mean, oh, I'm so sorry, man. Do you mean, I'm so sorry, bro. Yeah, I'm so sorry. I totally forgot. As you can tell, I'm not really a Discord dude. Yeah. Anyway. Yeah, Desp, let me do a rundown again, really quick. I'm gonna get back to the Game Boy Advance stuff, but I really kind of want to do this right now, only because this is somewhat pertinent to my job right now, kind of is, using a similar controller and stuff. I am making a roguelike in a language called Axe for the T84 Plus calculator, and it is C-like. It has a bunch of control statements and stuff. It has a ton. But if you know the Z80 assembly language, and if you know a bit about the Z80 assembly language, and if you know a bit about how the calculator hardware works and how everything's connected, you can sort of look at these functions and sort of like, I have an idea of how this works in assembly. It is a compiled language. You can compile it on the calculator. You can edit it on the calculator, but oh my god, I don't want to write all this stuff out on my calculator, so I'm doing it here. It is a language created, well, finished in 2012 by crazy calculator guys, way better than me, than I ever could. And yeah, I've wanted to make roguelike for it for a while, and I'm gonna do a roguelike in it. So let me show you what that would look like. So right now, this is my roguelike. As you can see, I have collision detection, but the screen doesn't scroll, and that's very frustrating, and hopefully we can figure that out tonight. It's a very simple going over again. In this language, you have the first comment being the name of your program that shows up on the calculator. As you can see, rogue right here. Rogue, even though it's called rogue source. Program floor source, that's just include. You include this, and this is my tile map for the floor I'm using. And this is my sprite map. I have the wall tile. I have the floor tile. And I have the scatter tile. And as you see that they're all 3 in a row, that's so I can index off of each one and say, the tile map says a 0. Let me draw offset 0. The tile map says 1. Let's offset 1 times 64, like 1 times 8, so I can draw a sprite. That sort of thing. Get calc temp RAM is just grab 12 bytes of RAM, return to a pointer A. A in brackets with a shorthand for a radian sign is 16-bit. Store 8 into 16-bit value. Store 8 into 16-bit value here. So your player X, player Y. Now, it's not player, like position 0, 0, 0, 1, 0, 0, 2. It's pixels. So it's 0, 8. It's 8, 8, 8, 16, because I have an 8 by 8 sprite. So in order to not max out my map size at 32 tiles, I have a 16-bit value. So yeah, and it's just things that you just have to remember as a 16-bit value to multiply and divide later on as you need to. Right now I don't have those working. Yo, Arisu. We're making the calculated game. 1 sort to XY. If you know how this stuff works, here, let me just do it. It's literally doing this on your calculator. That's literally what it's doing. But in this case, it's compiling. So right now I have X and Y for my player X and Y because I just haven't really figured out how to implement these yet, which is a shame. I need to get that fixed. Anyway, repeat is repeat. So I have a repeat and I have an end. That's just a while loop. Get key returns what key is being pressed. No, calculator. And 15 is the clear button. And 1, 2, 3, 4 are the arrow keys. I think it's like 1, 2, 3, 4. Yeah. Y minus 1, Y plus 1, or Y minus 1, 4, 1. Yeah, it's 1, 2, 3, 4, something like that. Anyway, the question mark is actually an and. So it's if get key 4 is pressed and TCH X Y minus 1 is true. And what is that? Well, that is just my collision detection. Return this value. And what is this value? That value, if you notice, it looks no different than y times length, or y times width plus x, which is how you access a two-dimensional array in a one-dimensional tile map. Yeah, and then this is the offset. So basically, grab this get the offset. And you may be wondering, well, what is the offset? Well, remember, the tile map is a map of what offset in the sprite tiles to do. Because if I have 0, 0, that means grab the first, pick 0, 0. So, yeah, and then if I say 0, 1, then grab the next one, which is the floor and stuff. So, the wall is the only thing 0, so if I return 0, anything, and 0 is going to return false, so it's not going to run. So right now the only thing I can run into is the wall, which honestly is fine. I have to do other different collision detection anywhere else. Update the window coordinates. Well, this doesn't quite work, so let's just delete that right now. Display label DP, right? So this is supposed to set up the camera coordinates. So we have to update the values at a plus 4 and a plus 8 before we can get anywhere. A plus 4 and a plus 8 is divided by 8 because you use those to basically shift the entire map around. So what's going on. E and F are the for loop variables. 0 through 7, so that's 8 sprites tall. 0 through 12, that's 13 sprites wide. That's how wide the screen is. And if you look at 4.1 source, that's actually exactly how big it is. Should probably do 11. Cool. Let's say project test. And let's just try compiling it again. Pile .cs. I think that looks right. I'm not drawing anything I shouldn't be drawing. Looks good. There are going to be quite a bit of magic numbers here because I have that many variables. So basically, this just grabs the where I am, and then pt on is a pointer, is a sprite. Put a sprite there. Sprites are assumed to be 8 by 8 pixels, so don't have to manually draw each pixel out. And then the minus C and the D is supposed to, well, it's supposed to be for the it's supposed to be able to draw everything offset for the camera cords. Draw a player, PT off, use the player sprite. Disk graph clear draw is clear the main buffer and then draw. It's just as fast as just disk graph. Yeah, then that's the code. And now let's try to make it scroll. So let me just do something here. Let's say 1 is stored to C and D. So I'm expecting to see no wall. I'm expecting to see some stuff. Generally with Axe, the smaller your code is, the smaller the actual compile binary is too. Also know that accessing, ooh, that's not at all what I expected, but the devil is in the details here. I think if I said 8 stored to C and D, it could possibly yield what I want. Look at that. It worked. C and D work. But if you notice, there's two problems. There are two problems here. One is, let's change that to 0. Let's compile. Oh, Lord, God damn it. I hate it when it does that. Oh no. Hang on one moment. Okay. Okay. Here's the problem, folks. Notice that I have, there is a wall, there is a floor, and there's a wall group here. There's a wall, there is a floor, and there's a wall group here at the very edge of the screen. Let's change this to 8. Again, now what I expect to happen is to just have everything shift up to the left. So I should see, I think, I don't like what I'm seeing. I'm seeing a floor, 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 and there's nothing. There's nothing over here. Why is that? Why is that not drawing? If I do a 16, compile, source, isn't that funny? I think you can now see what the problem is, or like what problem I'm having. So let us figure this out. So let's say row plus C let's move this out of the loop. Cool. C plus D. I think that might help my problem of incorrect collision detection. That didn't work. Oh, you know what? I think this is actually And if I want to get in there and like really figure out how to do it, I think what the way Axe does is I think it's like a accumulator. So if you don't have parentheses, everything will just get stacked onto the end, left to right. But if you have parentheses, it'll increase the code size. See, look at this. Isn't that terrifying? This is terrifying, dude. There we go. My collision detection works. So, yo, Mohammed, what's up? What is good? Just here, cutting some stuff up. No, Des, but no. Next time I stream, I'll definitely be I'll be doing the Game Boy Advance, getting that done. Anyway, so this clearly will work, but how do I? Oh, is that from a calculator? I'm trying to make a roguelike for the TI-84 Plus using a language called Axe, which is a compiled language. Basically, I need to say if X is greater than, well, here's the thing, that's, how do I make a scrolling window? Why is it, this concept is just so hard to me. Why is this so hard to me? Let's see. I don't know. Yeah, I know. Let me try asking Gemini here. I want to make a rogue like with a scrolling window. I want the map to be larger than the viewing screen. I want the player to move around the viewing screen until I reach close to the edges. Then if I move away, still have the whole map scroll and keep the player in the same place on the viewing screen. Basically, I just want you to be able to free move around here, like essentially your entire screen, and then if you move left again, you're gonna just instead have the whole map move. Okay, I think I think I got it. I think I got it. I'm gonna have C and D start out as 8. No, you know what? I'm gonna get rid of this because I don't need the 16-bit value for the camera. So C and D no, I do. Damn it. I'll figure it out later. $16 or 8, right? So I'll have like 0. Right now I'll do 0. Then I will have if x equals, and if I am correct, yep, cool, returns 1, not equal, cool. Set of equal. If x equals, well, my screen width, which is 12, if x equals 0, update. Maybe I should do this. Update the window chords first. No. If x greater than 12, greater than 11, damn, what am I? Trying to make a scrolling screen here. Let's take a look at Gemini and see what it had to say. Let's outline a plan, make it work with the scrolling window, addressing the map size, viewing area, and player movement you described. We'll focus on the core logic and concepts, which you can then adapt to your choice of programming language and libraries. Python with Pygame, JavaScript with Canvas, yes, you should get on that. Map opportunity, array, list of objects, right? Got it. Player position. Store the player's position and the coordinates within the map. So I need map coordinates for your player. That's going to be my X and Y. A view window. Store the top left corner coordinates of the row column of the currently visible map. That is the viewport. That's going to be C and D. Initialization. Generate your map. Place the corner, initial set location, initial view. Set the window's top left corner so that the player is centered or near centered in the initial view. Rendering. Drawing the map. Iterate through the rows and columns of your view window. For each cell in the view window, calculate the corresponding map coordinates. And your map coordinate is going to be C and D being offsets. Player movement. So I think that's fine. Rendering I have sorted. It's the player movement that I have problems. Input. Get your input. Yep. New player position. Calculate the new intended new position on the map. Check for obstacles. Update the map X and map Y. Exactly. This is the core of my question, the scrolling logic. So new player is just change dx dy. Makes sense? Okay. I think I'm getting an idea. Basically, if I'm within the bounds, but I don't really care. Basically, that's just because. So I need to do this now, the scrolling logic part. You know what? Really quick, I'm gonna go grab some water. I'll be right back. And I'm back. Moment. Cool. I think I have. So this will be what I'm looking for. Scrolling. If my x is less than my view x plus scroll margin. My scroll margin okay. If I'm trying to understand what this means. If my x, if scroll margin, hang on. Let me just copy and paste this. If C plus scroll margin what the hell is scroll margin? Let me what is scroll margin in this context? how close the player can get to the edge of this view window before the map starts scrolling. So let's say if c plus 1 is less than x, okay, so then that means something is going to be set to x. So, and it, yeah. That means I'm going to set max 0 x minus 1. Is going to be stored to view x. This is by far the worst code I've ever looked at for readability. Okay, look, Des, do you know why this is the worst code you've ever looked at for readability? It's because you're programming it on a calculator. And the thing is with these calculators is, unless you're using VMS for the on-calc assembler, it's tokenized. And it's using the TI basic tokens as opcodes, essentially, in a compiler. So that's why it's so trash looking. I grew up on this stuff, so that's why it makes sense to me. But, yeah. Returns greater than 2 values. So I think the code just makes sense. Okay, so then, okay, don't scroll past the map edge. Okay. Else if C plus view width minus scroll margin, and view width I think is 12. Well, let's take a look. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, we got 12. So view width is 12. View width plus 12 minus scroll margin. And the opposite of greater than or equal to is less than. And we're going to say something is stored to view x. Oh, right. And it's not even that. It's going to be c times 8 stored to c. Right? Because you gotta scale c for it to work. We got min 12 minus 1 x minus 12 plus 1 . Else if, and the reason I'm writing it like this, is for optimization purposes. I could use parentheses and all that, but like it's just so slow on the compiler and bloated. If I need to, I need to. If I might as well just if else if y less than d plus 1. This is going to be stored to d. Max 0 y minus 1. And then d times 8 store to d. Else if y is greater than or equal to d plus 8 minus 1. We got d times 8 stored to d. We got min 8 minus 1 y minus 7 plus 1. Let's do 8. And then at the end, we have to have the end of the chain. And then because these, let's try it. I have horrible feelings. Invalid token. Oh, whoops. I totally left this in here. What? Oh, no, King. No, it's all good. It's all good, homie. No. This isn't a fault of Desp or anything. This is just the nature of the source code. It's just nature. It's just the nature of how this programming language works. It has to do a lot with very little on the calculator. Because if it was a full C parser, you can only have an 8 kilobyte executable natively on this calculator. You can have a bigger program, but you can only execute an 8 kilobyte chunk. It's a mess. So yeah, can I read it? I can read it. It takes a bit. Yeah, no snarkiness, homie. It's not needed yet. Okay, let's see. Oh my god. Whoa! Something's happening. By the way, I'm learning Java and Rust right now. Don't recognize this language. Right. This is awesome for you learning Rust. This is Axe. This is a programming language. It's not officially sanctioned by Texas Instruments, but it was a project from back in the day. It was a project from back in the day that allowed you to program the TI-84 Plus on calculator without having to use your desktop in something that wasn't as slow as BASIC, and something that could have been easy to code for and something easy to compile. It compiles down to Zlog ZAD assembly. So I consider it somewhere between assembly and C for the calculator. And it has tons of instructions. It's a very wonderful language. A labor of love, really. Extreme labor of love. Anyway, so let's see what's going on. If I go down a little bit, it works. See, it's scrolling. Oh, uh-oh. 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 It's scrolling. Oh, God. Okay. Let me read through my code and see what's going on. I think I know immediately what's going on. I'm not scaling things. So I have to scale. I have to divide by 8. I have to divide by 8 in the checks. Brother, instead of giving a hand of complaints, why don't you just say something? Bro, right, King, come on, man. Right, King, there's literally no need for this right now. Or either of you two. Jesus Christ, homie. It's just a YouTube stream of me making a game for a calculator that's related to work. Come on, guys. Okay, let's try this. Okay. I don't know what's going on. I think... things are still getting crazy here. I think we're on the right track. So, let's see. 0, C, and D. C and D are stored as... Should I store C and D? No, I can't because I need this. Hang on. If X is less than I don't need to okay, let me I think pause does what? Pause for the given amount of time. A 1 second pause is around 1800 in normal mode or 4500 in full speed mode. So let's say at the end of this all, let's say pause 18 let's try that just so I can at least be able to see what's happening. Okay, makes sense. Okay, so we're gonna go to the right. This isn't really what I wanted, but whatever, it's fine. Okay, so I have 11, And now I'm going to hit 12. X will now equal 12 because 0, 0 is actually the upper upper left corner of my map. Okay, so it's 12. Right now it's 12. I'm at the edge. Now if I go to the right one more, what happens? I am drawn not on the screen, but the tile does scroll. Okay, I'm going left, right, and I'm hitting the wall right now. I can't go right anymore. Now let's try going back to the left. Interesting. Interesting. What? What? Anyway, I don't know what was going on there. So now let's try going down. So I'm gonna hit down. 3, 4, 5, 6, 7. Now I'm gonna hit 8. Okay, scroll down. 9, 10, 11. Doesn't work. I'm going up again. I don't know why I'm running into something. Why am I running into something? Let's go down. Let's go up. I don't know why I'm running into stuff. Why am I virtually running into stuff? I just jumped through some walls here. Okay, so scrolling somewhat works. While we're at it, let's actually just move the pause to just here. I know it's not it's not ideal here. Check the number of guys you might be put wrong. I mean, honestly, that really is probably just the problem here. I want to see how big that is with like 4 calls to pause. Okay. What's going on? If okay. Why is it max? Let me ask why this is max. Do we use max min? Doesn't that clamp stuff? Okay, the max and min functions in the scrolling logic are indeed used for clamping or constraining the view window's position. This is essential to prevent the view window from scrolling beyond the boundaries of the actual map. Okay, that makes sense. Let's break it down again, max and min, preventing scrolling off the left top edge. So, max 0 ensures that the view x and view y never become negative. Okay. Oh, because if it goes negative, you just clamp it to 0. Okay, cool. Um, okay. Why is this so hard? If my x position is less than 0 minus if it is greater than or equal to 11, let's look. We got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's try this. Okay. 1, 2. Okay, so we're going down. I'm gonna hit 7. Scroll. Up. 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 Why does that jump? It jumps because the screen scrolling just isn't right. That's why it jumps. I think something is happening to my X and Y position. Well, let's go up. Nope, it's not jumping. Then if I go down, scroll, 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 up, 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 up. Why is it jumping? Okay, so up is the max, right? Is that what it said? Left and top edge. View Y. Let's do that. This is what's wrong. Got no idea what's going on. I have an idea of like what I need to do. This is just so bizarre. Okay, I'm gonna move down. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I don't know what's going on. What is going on? Okay. C divided by 8, stored to M. D divided by 8, stored to N. Camera X, camera Y. And let's just take this. Put it over here. So now I can use the same screen space. If Y Y less than N plus 1, N plus 1 is camera Y, then max 0, because I want to clamp to 0, yep. Okay. If Y is less than 2, why is this so hard for me? I'm trying to wrap my head around this. what if I'm just gonna do this because I don't even know anymore. I shouldn't need this. What is going on? So hang on. So we got 0, 1, 2, 3, 4, 5, 6, 7. Zero, 1, 2, 3, 4, 5, 6, 7, 0. 0, 1, 2, 3, 4, 5, 6, 7. Okay, let's try this. 0, 1, 2, 3, 4, 5, 6, 7. 8. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. What am I running into? What am I running into? It's like I can't. What is going on? Hang on. I am really lost. How do I make a scrolling map? Well, the map scrolls. You know what? Actually, before we even do this, it doesn't draw when I scroll, right? So if I keep going over here, right? It's just not even drawing, right? So let's fix that. Hmm. Zero, 7. And C. My God, why is that so complicated? Hmm. Let me take a look. Let me take a look at my old code. What did I write down? PDF, A times A, okay, B plus V. So the first loop, E plus V times G V is the camera offset. Oh, I see. So I got this B, which is E plus camera offset times G plus the width plus okay, I got it. Oh, it's saying a whole lot here. I'm just really lost. Why would this not draw anything beyond the stuff? I'm gonna just remove these divide by 8s. I guarantee it's gonna break literally everything. Let's find out, you know? I'm sure it's gonna be horrendous. 2, 3, 4. Okay, so far it's working, but I don't know yet. That's terrifying how nothing happened. let's just do this. Man, I was really hoping this could actually work a little better. So if you notice what's happening here is, if you look at it, I'm going down 1, 2, 3, 4, 5. Now, when I go down, I shouldn't jump the screen. See, it jumps. So let's get rid of that. Let's go back here. Change this to 12. Change this to 12. Change this to 12. Change this to 8. Change this to 8. Change this to 8. Let's see if that works. Okay, let's go down. That's 1, 2, 3, 4, 5. Now, if I go down one more, it shouldn't scroll. It doesn't scroll. Now it should scroll. My character should stay where it is, and the map should scroll around me. Nothing is drawn.